All right, students, this is the continuation of the notes 4.3. So this is part 2. Part 1 was the angle bisector stuff. Here, now that you know about angle bisectors a little bit more, we're going to apply it and find the incenter. So the angle bisectors of the angles of a triangle intersect at a point called incenter. So it looks like the circumcenter, but this is different because of how it's created. This one is talking about the angle bisector specifically. So if this line was to go this way and this angle bisector was to continue all the way, and if this angle bisector right here continues all the way, they will all meet at that point in the middle. So that's incenter. What happens here is similar to the application of angle bisector, is that it creates equal sides or congruent sides. The only annotations that you had here were the 90-degree angles. So that makes the connection that an angle bisector and the 90-degree angle create two equal side lengths here, or not side lengths, but segments. This angle bisector and this 90-degree annotation creates two equal segments, and then this angle bisector with the 90-degree annotations create congruent segments. So to finalize that or summarize that, we need to remember that there's equidistant sides once these angle bisectors are created. Let's see, angle bisectors. Let's identify those. So PV. PV is this one right here. PC, which is this one right here. And PA. Those are your angle bisectors. The incenter is labeled P. And the congruent segments that are created are these. PD, so from P to D, is congruent to PE. So these two right here. And PF right here. So let's annotate those as well. Let's put 4 little dashes on those. Okay, so these are all equidistant. AD is congruent to AF. So AD, AF. BD is congruent to BE. BD, BE. And CF is congruent to CE. CF, CE. So now let's apply those congruency statements on these examples. So first we need to find NP. Let's look at N and P. So it's this part right here. That is equidistant on all ends. So we're going to say this is the same as this and that. This 8 is given to you in this one, so that means NP is the same as MP, which equals 8. NK, let's see. NK is that one. And if we're going to annotate congruency, we're going to say that these two sides are equal. NK is congruent to KO, which results in being 17. Next, we're going to look at PK. So P to K. This one, you're going to have to do some calculations here because of the missing measure. And if you look across, you have this right here being equal to an 8. So we're going to look at the triangle. Let's see. PK is going to be calculated with this triangle right here. This side is 8 because that's the equidistant side. This side is 17 because that's what it says right here. So we're finding this side. 90 degrees right here, so right across that is the C value. So we're finding the C value. We're going to use Pythagorean theorem. So A squared plus B squared equals C squared. We don't have C, so that's your A and B. So 8 squared plus 17 squared equals C squared. We're going to just type that in the calculator to make this faster. So we're going to have 8 squared plus 17 squared, and that equals 353. So we have 353 equals c squared, which means the square root will give us our answer. And let's check that. Square root of 353 is 18.78. So let's write that down. We're going to have 18.8 if we round it. Just an advice, once again, there are shortcuts for you to do this in one calculation. So because it's a hypotenuse, we could have done c equals the square root of 8 squared plus 17 squared. And then just type that in the calculator and get the answer. So let me show you. We could have done the square root of 8 squared plus 17 squared, and then it's the same answer. So if you learn the shortcuts, you'll be saving yourself some time. All right, let's try the next one. LO. LO is right here. 13 is given right here. And we know 8 is that. So now let's sketch that. I forgot to put 8.8. All right, let's sketch LO. For LO, we're going to have to look at the triangle that's created like this. 13 is the hypotenuse. This is your 90 degree. Because of this being 90 degree, then this is also 90 degree. And then this side length is 8, because 8 is all the way across like that. So it's 8 right here. And LO is this side. So we don't know that one. 13 is across the 90 degree angle, so that's your C. So we're going to do A squared, let me separate this, plus B squared equals C squared. A or B, one of these. Let's just do 8 for A and B for that one. 8 squared plus B squared equals 13 squared. 64 plus B squared equals 169. Subtract 64. B squared equals 105. So if we do the square root of that, we'll get our answer. So the square root of 105, it's 10.27. So let's just round that to 10.2. All right, so let's do 10.2. And then just once again, the shortcut to this, because we're now missing a leg, is doing the square root of the hypotenuse, which is 13 squared, minus the leg that you're given, 8 squared. So that one is, if we type it, square root of 13 squared minus 8 squared, and it equals the same. So if you want to go back to your Pythagorean theorem notes and add those shortcuts, you can. I forgot to mention them in the video. So these are notes 4.2, and right here below you can do shortcuts. To find the hypotenuse, we're going to do C equals the square root of A squared plus B squared. To find the legs, you're going to do A equals the square root of C squared minus B squared. Or B equals C squared minus A squared. Sorry, right there. All right, so take those notes on your right triangle notes 4.2, and let's practice and use those as needed. Okay, so this is the time where you will pause the video and try these examples without me, or just keep watching, but just try some on your own to make sure you're mastering this topic. Here it tells you G is the incenter of ABC, so this has to relate to the angle bisectors. GD, let's see. GD is this part right here, and we said it was equally distant all the way. Now, what information are we given here? Well, Let's see. It looks like we're going to have to do Pythagorean theorem with these two numbers. GD creates this triangle right here, 90-degree right there, and it has a 37 as a hypotenuse and 35 as a leg, and we don't know this part. So that is a leg, because right across the 90-degree you have 37. So because we're missing a leg, we're gonna maybe do the shortcut of writing A equals square root of C squared minus B squared. This is the shortcut of Pythagorean theorem. So we're gonna do A equals the square root of 37 squared minus 35 squared. If you're confused as to why we're doing this, you could do it the old way and substitute the values and then realize that you're going to square these numbers and then you're going to have to subtract this from that. So that's what's happening there. Okay, so let's type that. Square root of 37 squared minus 35 squared. And that results in 12. So that means your side length is 12. Okay, next is BG. So now let's look at BG, B to G. So now we're looking at this perpendicular bisector. No, I'm sorry, angle bisector, knowing that this is 6, and knowing that we just figured out what that side length is, which is 12. So for that one, let me just make some space here. For that one, for BG, we're going to do a little sketch of what we have. And we know that this is 6 on this side, and we just found out that this part is the 12. So we're just missing that hypotenuse. So for this one, if you want to do the shortcut, we're going to do C equals the square root of A squared plus B squared. And once again, the reason why is because you already have A and B, so you just got to square them and add them, and then do the square root of the answer to get your C. So that's what's happening here. So we're going to do C equals 6 squared plus 12 squared, and do the square root of that. All right, 6 squared plus 12 squared, and that's 13.4. So we're going to write 13.4. All right, next is FC. FC, this distance right here. So understanding that you have that angle bisector right here, we can say that these two are equal. So therefore 35 is here, 35 will be there as well. So we can say FC is the same as DC, so that's 35. Okay, 35. And last one, BF. So let's look at that. BF right here. So since this is an angle bisector, let me do another cutter. This is an angle bisector. We are to assume that these sides right here are congruent. So this is 6, therefore BF is 6. So BF is the same as BE, which is 6. Okay, so all this work that I'm showing you is a way to justify your answers whenever you take a test. All right, one more problem will be done with this video. This one says if S is the incenter of triangle PQR and PRQ, so let's highlight that, PRQ, this angle, is expressed by 8x minus 11. So this right here, both of these, It's 8x minus, oh, sorry, minus 10. Then RPQ, let's see. Oh, I think I wrote it wrong. I'm so sorry. PRQ is going to be, let's just do it orange. PRQ is this part right here. That one is the one that's 8x minus 10. And RPQ, so RPQ, that's the yellow one, will be 4x minus 14. Okay, and then it says PQR, this one, it's 7x minus 5. And now you're being asked to find these side lengths right here. I'm sorry, these angles. Before we continue, let's talk about what you're given. You're given angle bisectors. All of them have angle bisectors. So that means if you find the whole angle, you will have to divide to make equal angles. So like these two will be equal and these will be equal. All right, so first of all, let's talk basics. What do you know about all three angles? All three angles add up to 180. So we're gonna find out what x equals by doing this equation. 4x minus 14 plus 7x minus 5 plus 8x minus 10. And we combine like terms, so all the x's, 4x plus 7x plus 8x, and then all the numbers by themselves, so the constants, negative 14 plus negative 5 plus negative 10. So these right here will give you 19x, and these right here should give you negative 29. All right, so then now we solve for x by adding 29. 19x equals 209. Divide by 19 and x equals 11. So now we know 11, we can plug in 11 there. We can plug in 11 here. And we can plug in 11 right here. To find the answers, 8 times 11 is 88. 88 minus 10 is 78 degrees. And then this one will be 7 times 11, so that's 77 minus 5. So this one will be 72 degrees. And then this one right here is 44 minus 14, and that one will be 30 degrees. Okay, so just to kind of sketch a clean version of this, we have an angle right here that's 78. We have an angle right here that is 72. And we have an angle right here that's 30. And when you draw those bisectors, we cut these in half. So half of 30 is 15. So 15 and 15. Half of 72, I believe, is 36. And half of 78 will be 39. Okay, so with those annotations, let's answer what's being asked over here. PRQ. PRQ, the whole thing. So we said that was 78 degrees. All right, RPQ. RPQ. So this corner right here, that one we said it was 30 degrees. And then PQR, this one right here, that one was 72 degrees. Next is RPS, so just one little half of that, not both. That means half of 30 is 15. And then PQS. So PQS. So one half of this one right here. And half of 72, we said it was 36. PRS. This little part right here. So that's half of this angle, which is 78. So half of that is 39. Last one is PSR. Which is this angle right here. For that one, we're gonna have already these two angles, and now we find that one. So I'm gonna write that here as a sketch. So measure of angle PSR can be calculated by looking at the triangle like this. Sorry, my sketch is not the best. But this part we said was 15, because that's half of the 30. And then this side we said it was 39 because it's half of the 78. So we have 15, 39, and then this is the one we don't know. So once again, all three angles add up to 180. So we have 15 plus 39 plus x. We don't know what that angle is. 15 plus 39, that should give us 44. Let me just double check. It's pretty late. My math might be wrong. So 15 plus 39. 54. See? All right. 54. And that plus another angle is 180. So we're going to subtract 54 from 180. And that will give us our x. That will give us our missing value. So 180 minus 54, that's 126. And that will be the answer here. 126 degrees. All right, I know it was a long video. I hope you hang in there watching all the steps, and I hope it helps you.